Friends, we will solve another question. The question says a Carnot heat pump works between 27 degrees Celsius and 327 degrees Celsius. What will be its COP? So क्वेश्चन पूछ रहा है कि कोएफिशिएंट ऑफ परफॉर्मेंस निकालना है और एक हीट पंप है जो कि 27 डिग्री सेल्सियस और 327 डिग्री सेल्सियस के बीच में ऑपरेट कर रहा है. लेट्स सॉल्व दिस क्वेश्चन. So I will just first draw a simple block diagram or a line diagram for a system working between the two temperature limits. So suppose this is the device that is acting as a heat pump and is exchanging heat between two reservoirs. दो रिजर्वायर दो हीट के सोर्स या दो सिस्टम आप मान लीजिए. लेट अस कंसीडर टू रिजर्वायर्स. सो अभी हमने रेफ्रिजरेटर के क्वेश्चन को सॉल्व किया था. सो व्हाट वी वर डूइंग, अ रेफ्रिजरेटर विल maintain a body at a lower temperature. And how? By continuously rejecting heat from a system, heat out of a system, and rejecting it to a system at a higher temperature relatively. So when a system is rejecting heat continuously out, so it will be maintained at a lower temperature. But just reverse in the case of heat pump, a heat pump will allow a system to remain at a higher temperature to get more temperature relatively. सपोज दिस इज अ सिस्टम, ये एक सिस्टम है, एक रिजर्वायर है, इसको हमें गर्म करना है तो हमें इसे और भी हीट सप्लाई करने होंगे. और ये गर्म कैसे होगा? जब इसके सराउंडिंग्स में रिलेटिवली लोअर टेम्परेचर होंगे. सो यहाँ पे सेम फिनोमिनन है, हमें वर्क इनपुट चाहिए. वर्क इनपुट और ये दिस इज द रिजर्वायर और सिस्टम विच इज़ मेंटेन एट अ लोअर टेम्परेचर. यहाँ से ये हीट रिजेक्ट करेगा. सपोज दिस इज द हीट रिजेक्टेड आउट ऑफ द कोल्ड बॉडी और द सिस्टम मेंटेन्ड एट रिलेटिवली लोअर टेम्परेचर. और ये यहाँ QH मान लेते हैं. दिस इज द हीट सप्लाई टू this system maintained at higher temperature. This is the body, this is the area where we want to maintain a higher temperature, suitably higher temperature. Generally ये विंटर में देखा गया है कि हमें हीटर्स क्या करती हैं, एक स्पेस को गर्म रखती हैं. तो वहाँ पे हीट फिनोमेनन, हीट पंप की वर्किंग आती है. और रेफ्रिजरेटर की ज़रूरत आती है समर में जब हमें कूलिंग चाहिए. So this is the space where we want to cool. This is the space where we want to cool by continuously rejecting heat out of the system, right? So again we will write the formula of COP. It is nothing but in case of refrigerator the COP was TL, that is the temperature of the body maintained at a lower temperature upon temperature of body maintained at higher temperature minus TL. So in case of heat pump, this is the coefficient. This in case of refrigerator, this is the refrigerator. In case of heat pump, how we will write the formula? So in numerator you will write TH, right? And in denominator TH minus TL, right? So we have the two temperature limits. 27 degrees Celsius. 27 degrees Celsius will become the temperature of the body system maintained at lower temperature. So TL is equal to 27 degrees Celsius. And always we are converting Celsius into Kelvin. 20, and how we convert? So we add 273. So this becomes 300 Kelvin is the temperature of system or space maintained at lower temperature. Again we will convert the temperature of the body system maintained at higher temperature. So the higher temperature in Celsius is given as 327 degrees Celsius. So we are again supposed to convert this. So what are we gonna get? 7 3 10. This is 1 7 to 9 10 again, and this is 600 Kelvin. So we got the temperature of the two reservoirs and in Kelvin. So we are gonna replace this with, insert the value in the COP formula. So COP TH, we just got the value of TH as 600 upon TH again in the denominator 600 minus 300. So what we got, 600 upon 300 is equal to 2, and this is what COP of heat pump. COP of heat pump, HP. In case of refrigerator we can just write in subscript RF stands for refrigerator, HP stands for heat pump. So we got 2. Now we will look at the options, and we have four options in exam. Similarly, you will find if the exam is multiple choice question, you will have four options. Generally four options are given, so we are able to get one of the options, and this is the right, because we have proceeded, we have followed the right approach and the easiest approach. So this is the 2, so we got the answer is 2. This is the 2. So the working is same, and the approach is same as we have followed. And in case you have missed the video to see how to find COP of refrigerator, you can follow my video, you can watch my video. I will put the link in the comment, you can just go through it. So this is how we have got coefficient of performance of heat pump. And in the next video we will see the vapor compression cycle and the relation between coefficient of performance of heat pump and coefficient of performance of refrigerator. Very simple approach and tricks I always try to put in the video so that all will understand and they are able to hit the questions in the exam, whatever exams they are writing. Suppose it is sscje, rrbje, you write many exams, state, psca, so this will help everywhere. Thank you, we will meet again.